do here. On Friday, you're going to get a quiz. Listen to me. Everybody listen to me. On Friday, you're going to get a quiz. I'll explain it in detail tomorrow, but I'll basically tell you right now. You're going to get a quiz on the homework you just got back. I'm going to go over them answers right now. And the homework you're turning in. That's it. It's those two things. I'll explain it more in detail tomorrow. But I just wanted to let you know. Friday. On Friday. I don't think it'll take the whole period, but that's all we're doing Friday. When you're done with the quiz, you're done for the period. You just do whatever. Okay, now look at the homework paper you just got back. Some of you, I already talked to a couple of you. I don't know. Did anyone else have "see me" written on the paper? You did, John? Okay, the first 5 problems, 5, 6, 8, 9, and 10, the directions said, find the sine of theta. And some of you found all 6 of them. You didn't have to do that. The first 5 problems on the homework you just got back, 5, 6, 8, 9, and 10, it just said find sine of s, and it gave you other information. So, let me go through these answers here. In number 5, the sine of theta equal, somebody, what'd you get? What'd you get for number 5? Come on, you got your papers there in front of you. Yep. Radical 7 over 4. In number 6, it said find sine of theta here. Somebody have that one? What do you got? David?
3 radical
Negative. It's negative because it said quadrant 4, okay? The answer to number 8 is negative radical 77 over 11. Negative radical 77 over 11. The answer to 9, now this is, well, let me see if somebody got this one. The radical on the top is kind of ugly. Let's see if somebody got this one. Number 9, sine of theta equals, John.
Radical 65 over 11.
No, the 11's right, that radical's wrong. Jack. Negative. Negative radical 105 over 11. Okay? Negative radical 105 over 11. And then number 10 was easy. It said cosecant equals negative 8/5, so sine is just a reciprocal, negative 5/8. Does someone need to ask me something there? This is going to be stuff that'll be on the quiz Friday. Shh. And then you had 21, 24, 25, 26, and 27. These are the ones where you had to find the rest of them. So I'm just going to read these to you. If you have a question, I'll take it. In 21, they gave the sine of theta. So cosecant was 3/2, reciprocate. Cosine was negative radical 5 over 3. So secant would be negative 3 radical 5 over 5. That's the reciprocal. The tangent was negative 2 square root of 5 over 5. So the cotangent is negative radical 5 over 2. Fellas, listen to me, because I'm going to do more of this today. You got to get used to all this. Look, I wrote them all up here again. These are all those identities or alternate forms. I didn't even start the proving stuff yet. Remember I said prove each identity? I'm not going to get into that till next week. And then wherever we end up before Christmas is where we are. There's not going to be a test. After this quiz Friday, there's no more tests or quizzes till after we get back. Dave? Negative 2 radical 5 over 5 was tangent. And then cotangent was negative radical 5 over 2. Number 24, the sine was negative 2/5. The cosine was negative radical 21 over 5. The tangent was 2 radical 21 over 21. The secant was negative 5 radical 21 over 21. And the cotan was radical 21 over 2. Boys, you did stuff similar to this back in the first quarter. You did do stuff like this earlier in the year. 25, the sine was 3/5, the cosine was 4/5. This one came out nice. The tan was 3/4, The cosecant was 5/3, the secant was 5/4, the cotan was 4/3. You know why those all came out nice? Because when you did your square root of or whatever, it was a perfect square. That's why those are all nice numbers. 26 also came out real nice. 26, cosine was -3/5, tangent was 4/3, cosecant was -5/4, secant was -5/3, cotan was 3/4. And the last one, number 27, the sine was -radical 7/4, the cosine was 3/4, the tangent was -radical 7/3, the cosecant is -4 radical 7/7, the secant was 4/3, the cotan was -3 radical 7/7. Do you need to ask me anything here? That'll be the first part of this quiz on Friday, that homework paper right there. Okay, I hope everyone's okay there. All right, take your notebook out. And write down these directions, right? Yes. Come on, hurry up. Don't be gone forever. Hurry up. Leave that door open. Write this down. These directions down. Write them down. Now, what was the directions to the homework you turned in today? This was yesterday's class. What did it say to do in the directions? What was the main thing I showed you yesterday, Jimmy?
Like, do whatever you have to do and then put it in terms of sine or cosine.
Convert to sines and cosines, that's right. And then simplify it. This is saying perform the indicated operations and simplify the result. Now put these two problems next to each other. That's example 1 and example 2. This is all, but boys, this is all preliminary work. What I'm doing here is preliminary work to proving identities. When I start next week proving identities, you're going to see why I've been doing this. Because it's all going to be part of proving identities. Now, do you remember the big thing I kept repeating yesterday? I kept saying all those things you learned in freshman algebra. Distributed property, Boyle method, adding fractions with different denominators. I started showing you that kind of stuff. You're going to do all that, but it's going to be with the trig functions. So this problem that you see right here, if that said x plus 1 over x, isn't that adding two fractions with different denominators? So you would get a common denominator? Do you understand what I'm saying? Well, that's what you got to do. Perform the indicated operation. Technically, that's over 1. So here's my first question. What's the common denominator? Obviously. What's the common denominator there? Ethan? Tan of x. So once you know what your common denominator is, don't you got to multiply this by whatever you need to get tan of x on the bottom? Do you understand what I'm saying? It's the same as freshman algebra, but it's with the trig. So I would like one of you to raise your hand and tell me what this fraction is going to become when you do that. Multiply the top and bottom by tan of x. Andrew.
Tan squared of x over tan of x.
Now, once your denominators are the same, what you do in freshman algebra? Make one fraction, right? Somebody, give me the one fraction. Look, make one fraction. Go ahead. It's on the board. Just tell me what to put up there. Chris.
Tan of x squared plus 1.
And squared x plus 1. Listen. You just performed the indicated operation. Now it says simplify the result. You did the operation. Now, this is gonna be the whole key to this proven identities. Now you gotta look for opportunities to use these identities now, to make your answer simpler. Now, the numerator is practically jumping out of the board. Something. Numerator. Tan squared of x plus 1, what's that equal? That's a perfect application of one of these identities behind me. Rob?
Secant squared of x.
Everybody? 1 plus tan squared, that's secant squared, right? So we got secant squared over tan. Who has a question? Because today you got to stop me if you have a question. Yes?
In a fraction, don't you normally, like, if there's squared on the top, then, like, not squared on the bottom, don't you, like
Oh, you want to cancel? Is that what you're getting at?
yeah.
That's a really bad mistake. You want to know why? You can't cancel stuff when you got connected with plus or minus signs. You can't do that. If that was multiplied on the top, then yes, you could do what you're saying. But you'd be canceling a term with a term. You can't do that in algebra. Okay? So no, you can't do that. Now, simplify the result. Now this is where yesterday's class is going to come in. What do you think I want you to do with that stuff? This is yesterday's class right now. You really got to get good at doing this before we even start proving identities. What did I do yesterday? Somebody just told me, not even 5 minutes ago. What are you going to do with all that stuff? Adam.
Put it in terms of sine cosine.
Convert them. So question, what does secant squared of x equal in terms of a sine or a cosine? Get this down right here. What's secant squared of x? Convert it. Rob?
1 over cosine squared.
1 over cosine squared. Watch this. Over, what's tan of x? Convert it. Watch what happens here. Howard?
Sine over cosine?
Sine of x over cosine of x. Now, guys, let me just say this because I know somebody's going to do this, and you're going to, when you write these down, whatever that angle is, don't just say tan. Whatever that angle is, x, theta, whatever, you got to have that written there too. Now, isn't that an algebra problem? Fraction divided by fraction means multiply by the reciprocal. So here, I'm going to come over here. 1 over cosine squared of x times what? Dividing by a fraction means to multiply by the reciprocal. Joe.
Cosine of x over sine of x.
Now, do your normal algebra now. You're gonna hear me saying that every frickin' day, all the way to Christmas break. Do your normal algebra. Do you know how to multiply fractions? Of course you do. Are there any common factors you could cross out? Staring in the face. Somebody? Do you have a common factor there I can cross out? Oh, fellas, it's staring you right there. Chris?
Cosine on top you cross out, and the cosine, the square in the denominator.
If that was an x and an x squared,